texture, warmth, even pain, is not a direct interaction with the world. It's an illusion, a carefully constructed story our brains tell us based on a flurry of electrical signals. Our senses are our windows to the world, but like any window, they can deceive. We perceive solidity, a sense of direct contact when we touch, but this is a necessary illusion. In truth, we never truly touch anything at all. To understand why we can't truly touch anything, we need to delve into the very nature of matter itself. Atoms, the building blocks of everything we see and feel, are mostly empty space. Imagine an atom as a vast cathedral, with a tiny nucleus at its center, orbited by even tinier electrons. The nucleus is like a pea in the center of this cathedral, and the electrons are like flies buzzing around the periphery. The rest? Empty space. If we were to scale up an atom to the size of a football stadium, the nucleus would be smaller than a grain of sand at the center, and the electrons would be like tiny specks whizzing around the stands. So, if atoms are mostly empty space, what are we actually touching? The answer lies in the strange world of quantum mechanics. Electrons, those tiny particles orbiting the nucleus, carry a negative charge, and like charges, repel. When you try to touch an object, the electrons in your hand never actually come into contact with the electrons of that object. Instead, the negatively charged electrons in your hand are repelled by the negatively charged electrons in the object. This repulsion creates a force, an invisible barrier that prevents true contact. It's like trying to push two powerful magnets together, North Pole to North Pole. They resist, pushing back against each other. But what about the sensation of touch itself? If we're not truly touching anything, how do we experience the feeling of pressure, texture, or warmth? This is where our brains, the master illusionists, come into play. Our nerve endings are incredibly sensitive to changes in pressure and temperature. When we press our hand against an object, the electron repulsion deforms our skin and stimulates these nerve endings. These signals travel to our brains, which interpret them as the sensation of touch. We feel pressure, not because of direct contact, but because our brains are interpreting the signals from our squished nerve endings. Section 5. Virtual Reality, Exploring the Phantom Touch Illusion. Recent research has shed even more light on the illusory nature of touch. Scientists have been using virtual reality, or VR, to trick our brains into feeling touch sensations, even when there's nothing physically there. Imagine putting on a VR headset and seeing a virtual hand reaching out to touch a virtual ball. Even though there's no physical ball and your real hand isn't touching anything, you might still feel a sensation of touch in your virtual hand. This is known as the phantom touch illusion, or PTI. Section 6. The limits of vision. Why PTI isn't just seeing things. You might be thinking, well, maybe you just think you feel something because you're seeing it in VR. But here's the interesting part. PTI isn't just about what we see. Studies have shown that people experience PTI even when the virtual object touches parts of their virtual body that they can't see. For example, if a virtual object strokes your virtual forearm, which is outside your field of view in VR, you can still feel it, even though you're not seeing it. This suggests that PTI involves something more than just visual cues. Section 7. Unraveling the mystery, the role of tactile gating. So, if it's not just vision, what's going on? Scientists believe that PTI is related to a phenomenon called tactile gating. This is a process where our brains filter out the constant stream of tactile sensations we receive from our own bodies. Imagine feeling the sensation of your clothes on your skin all the time. It would be overwhelming. Tactile gating helps us focus on external touch sensations by suppressing the internal ones. Section 8. The body schema, our internal map of self. This is where things get really interesting. Tactile gating relies on our body schema, which is our brain's internal map of our body in space. This map is constantly updated based on information from our senses, including touch, proprioception, our sense of body position, and vision. When we experience PTI in VR, our brain is essentially updating its body schema to include the virtual body. The tactile gating mechanism, now applied to our virtual body, suppresses the expected touch sensations from our real hand, but since there's no actual touch in VR, we perceive this suppression as a tingling or phantom sensation. Section 9. Conclusion: rethinking reality, one touch at a time. The world, as it turns out, is not as it seems. The feeling of solidity, the directness of touch, is an illusion, a carefully constructed narrative spun by our brains. We never truly touch anything, separated from the rest of the universe by an invisible force field of electron repulsion. Yet this illusion of touch is essential. It allows us to navigate the world, to interact with objects, to experience the comfort of human contact. So the next time you reach out to touch something, take a moment to appreciate the wonder of this illusion. It's a reminder that reality is not what it seems, and our brains are constantly working behind the scenes to create our seamless experience of the world.